Hello, Arp. So here we are presenting the sixth laboratory assignment for EE542. So in this assignment, we are demonstrating Hadoop and Spark. So for this assignment, we are supposed to create wa- uh, four different instances for one name node and three data nodes. So in this assignment, we are asked to create the RSA key and then store it in the authorized keys file. So we change the permission for the file and we change the specific details where we'll have root at and the IP address. So we'll rename this to be Ubuntu at IP address for us to enable passwordless SSH. So we'll do the same procedure in the data node and the name node as well. Here after this we install Hadoop and then we unzip the Hadoop file and then add it into our file system. Then we open the dot profile file and then initialize our system variables. Before initializing, we also make sure that we install Java to execute Hadoop code. After that, we go into the folder of file folder of Hadoop to configure the internal variables. So in the Hadoop environment variable, we go and configure the Java path. In core.xml, we define the HDFS URL that we are going to use, and we define the temporary directory that we are using. In HDFS side, we define the replication factor, the name nodes file folder, and the data nodes file folder. We also disable the IP hostname check to make sure that we can allow the data node to connect to the name node. In the mapred site.xml, we use yarn for configuration, and the yarn site.xml we also define the host name which we'll be using. So after performing the configuration, we are able to go through for the SSH of different data nodes, and then we use the start DFS and start yarn process to start the node manager and the name node for the system. After this, we run the command hdfs dfs admin report. So we get the capacity and the live data nodes that are here in our environment. After this, we run a sample Hadoop program using Java to compute the value of pi. Sorry. So in this, we perform the map reduce method, which is already defined, and then we get the result here. So this ends the basic setup of Hadoop and the system keys for SSH as well. Now Vikram will continue with the demonstration of the mapper function and the reduction function, which is used in Hadoop to perform the word count.
Hey guys, welcome again. This is Vikram. So, Sarvesh might have briefed you about how Hadoop works, and he might have demonstrated to you the example. Now, I'm going to run a simple custom mapper and reducer function in Python to basically test our Hadoop system. Okay, this is a Gutenberg .txt file. So, we are going to test our Hadoop system with this .txt file. Okay, so let me go to my command line and as the report indicates, um, once we have completed the copy of the Gutenberg file in the local system, now we can run our MapReduce job function. Okay, and this is our mapper and reducer function. Right, that's it. Okay, so I will show it. So um, 1 second. So this is we have already ran it. So this is our 1 second. So we can run it. So it's running. Starting the map use functionality. Yeah. So the mapping is completed. Yeah, done. So it's done. So now we will go to uh, Gutenberg output to see whether the output has been successfully received, and we can see it's a success. Okay, we can cat the output using Gutenberg output part 00000. Yeah, right. So now, most importantly, we are going to do the second part, which is um, modifying the above program to find the most and least frequent words in the txt file. Okay, so we leverage the three data nodes and Hadoop to basically use the master node to separate to split out the file into multiple parts to the data nodes and compute. Even the compute part is being handled distributively. And finally, the output is stored in our server itself, our data node itself, 245 here itself. Okay, as we can see. So I'll show you the modified code. So this is our modified code, mapper one and reducer one. Yeah. So we're just adding some functionality to print the most frequent and least frequent words. Just a simple logic, count it, very simple. So let me run that code too. So before running that, you have to delete Gutenberg output. So yeah, 1 second. Let me go through it. It's pretty big command line. So let me first remove one R Gutenberg output. So what we need is we need to remove that Gutenberg output for Hadoop to proceed. Okay, so let's do that. Yeah. Now we will run the same command again. Okay. Now this time using reducer two and mapper two instead of map. Sorry, mapper one, reducer one. Not just plain mapper and reducer. Plain mapper and reducer is for the first case. Mapper one and reducer one is for the second case, printing the count of the words. Mapper one, reducer. Yeah. Yeah, I think it's good. Let's run it. Second. Yeah. So it's, as you can see, it's gradually mapping, and it will also reduce. Yeah, the reduction is 100%. That's it. The output is done. Okay. So we can similarly go and check the output. So we can go to yes, and we can see the success flag, and we can cat the content of that particular output file. Just sorry, I think I should sorry, I should navigate to that. Sorry, uh, sec. CD. All right, CD. Okay, what's my present directory? Okay, CD. Yeah, stop. Second. I think this is within the Hadoop system. So no, no, actually it's within the Hadoop system, right? So work output, fun cat, wouldn't work output, this one. So, sorry. Yeah, I forgot to delete that. As you can see, it's printing the count and the overall. You know. uh, 5. Overall count, most frequent and least frequent characters. It is also printing those. That's it. So this is how we leverage Hadoop to do this, achieve this functionality. Third, we will also optimize the Hadoop code to use generators, in Python, provided in Python, which is provided in the lab manual too. So we are just going to copy and paste this, and we'll see how this looks. So here we have our latest mapper 2 and reducer 2 functions, okay, which we have already copied from the report, and we are going to test it out in our Hadoop system. So here, um, so um, we have already copied our file system. So we'll just run the command. We have already pre-run the command. So we'll just rerun that again. Pre-run command again. So let me navigate to that. Mhm. So this is the same thing, but for Gutenberg 2. Gutenberg 2 is where we have the new dataset which we have stored. This new dataset is basically a file within that Gutenberg dataset. It's a TXT file. Again, it's a storybook basically in TXT. Okay, so we're going to uh, do the same operation that we did in our first case, but in a more optimized version by using generators given in Python. Okay, so we'll run this. Okay. Okay. I think I failed to remove the command again. Way back. Good. Output two. So we will remove that. So now we will run the command again. Okay. I think I probably need to recopy it. Okay. I think. Okay. One second. So we'll do this. Okay. I think. Yeah. Sorry. My bad. cd txt txt sec txt2. Yeah. Data file.txt. Okay. Um, we'll copy that data file.txt to file.txt is the story. So one sec. So we'll copy that. So so check this one. You see that? Okay, we will go through that again. Yeah, it's done. So now we will run the command again. Sorry about that. I my bad. Um, it's another file. Sec. Once again, probably there might have been some issues. Um, Steady mistake. Okay, okay. I should probably one sec. I know the mistake. Yeah, yeah. Sorry about that. Just copied it. I don't know why. Take my range. EXT. EXT. Stop this. Sec. Check whether it's so. Yeah. So it's done. So we'll go to the directory. Um, you see. Um, sorry. I'm Gutenberg too. Gutenberg. Um, output. Right. So we can see a success flag. Good. And we'll do the cat user Ubuntu Gutenberg output 2 dot 00000. As you can see, it does the same. Uh, first operation, much more, much more optimized code. That's it. Thank you.
So hello everyone, this is group 13 in the video demonstration for lab 6, Hadoop and Spark. So part 1 is Hadoop. So Hadoop is an open source framework that allow for distributed processing of large data across clusters of computer. So there are few key components of Hadoop like HDFS, MapReduce and Yarn. So uh, in our project, so yeah. So the key features and architecture of Hadoop. So the key features are scalability, fault tolerance, cost efficiency, and flexible. So this is architecture of Hadoop. So next is Hadoop distributed file system. So HDFS is primary storage system for Hadoop, designed for large file storage across distributed cluster of machine. So this is an output from our video demonstration, and this is screenshot example of code for Pi. This is an output screenshot for simple map reduce function, and this is output screenshot for most and least counted words across the file, or optimize map reduce. And we use a 4 number of worker node and got the following graph of execution time versus the number of nodes. So we can say that if we increase the number of worker nodes, the time taken also increases. Sorry, decreases. My bad. So part 2 is Spark. So Spark is basically an open source distributed computing system. The key features are fast processing with in-memory computation, and it supports multiple languages like Python, R, Java, Scala, and it is ideal for batch and stream processing. There are few components of Spark, just as Spark Core, Spark SQL, Spark Streaming, ML, LIB, and GraphX. So in this particular demonstration, we are mainly going to focus on ML LIB. So for our demonstration, we had the following configuration. We use the Linux version of Amazon Linux 2 AMI. Instead was C5 large, and we had a 12 GB of memory. So getting the after creating the instance, this was the step which we had to do for initial setup. So the first thing, we updated the system, then installed Docker, and then we started the Docker service, and then we added a mod as an EC2 user, and then we basically exit the machine. So this is a screenshot of initial setup. So as you can see, I am inside the EC2 instance. So now I'm installing the Docker image. So after installing the Docker image, we do Docker PS, which gives the following Docker container ID, its name, and its port number. So these are the commands which we need to do. So first we have to SSH into our EC2 instance, and we use the -l command to port it with our local system, and then we run the Docker image, and we start the Docker, and after that we basically have to log the name of which we get. So PySpark tutorial were divided into basically three parts. So first one was tutorial, so in which we had to do 6 steps. The first one was basic operation. It was just a get started with PySpark. So the first one was basic operation with PySpark. The second one was data pre-processing. The third one was building a data pre-processing pipeline. The fourth one was build a classifier. In this case, we use logistic. The fifth one was train and evaluate the model, and the sixth one was tune in the hyperparameters. So this is a screenshot of basic operation with Python, PySpark, sorry. So this is some screenshot for basic data preprocessing. This is creating a pipeline. This is creating the classifier. In this case, we use logistic regression. Here we train and evaluate the model. This is the best machine which we got. So the next part was we had to use the machine learning model on a UCI database for smartphone based recognition of human activities and posture dataset. So in this part we have to create a machine learning model and use any algorithm except which we used previously in the tutorial part. So in this case I use naive basic base for our model training, and the last part was we had to make a S3 instance and put all our data set on S3 instance and make an Amazon EMR and do it on cloud. So again we tested it with multiple of Spark worker node. So in this case also we had a significant increase in our time taken for execution. So there was also a question in that what is the basic difference between Spark and Hadoop. So Hadoop creates a distributed file system using name nodes and data nodes that try to parallelize computation using map reduce concept, sorry. And on the other hand, Spark uses a stream of data and internal resources to perform computation. Creating nodes in Hadoop could take a lot of time. It is easier to set up resources in Spark and hit the ground running. So this is the basic PBT presentation. Now I'll go to a demonstration of Spark. So uh, I'll uh, get into the EC2 instance and port it using -l command. As you can see, I'm inside EC2 right now. So I'll run the few commands. So it is now up to date, and then I'll install Docker. Then I'll go and I'll download the Docker image. Right. So I forgot this step. Sorry. Yeah. So I'll download the Docker image, and then I will do this step, and then I will install everything, and I'll clear it now. After that I'll write docker ps, and you can see that we got a name of this thing. So I'll copy this and I'll say docker logs, and we get a link to which we can get into this thing. So the first part was tutorial. So for tutorial we were given a link to which we have to follow, and there was a lot of typos which we have to fix. So I'll go side by side. So we did all this step, and now first we have to import PySpark and create a Spark context, and then we'll parallelize simple data, and then we'll say that take the first indices. So in this case it was 1. So now just print the square of these numbers. The next one was Spark, using Spark SQL. So we create a simple list of different names, and then we parallelize them, and then we create a map, and then we're going to create a data frame and print the schema. So after that is done, we are going to use a adult underscore data.csv and do some machine learning. So we add file using that URL, and then we added that context, and we read the CSV file. So we'll print the schema. So this is the schema of our data set. So we show the first 5 values. So this is very clustered, but yeah, this is the top the first 5 values, and after that is done, we will create a function known as convert column, and then we'll use some of the features in the data set, and we convert to the column, and then we'll print the schema again. So yeah, after that we'll use a string indexer. So we are doing some data pre-processing right now. So we'll select a few columns, and after that we will do a count by group by. So we'll see that how many people have completed a type of education, and we're going to sort this up in ascending order. After that is done, we are going to describe the data set. So first we'll describe the whole data set. So again, this is very clustered, so yeah. So after that is done, we'll describe a single column which is capital gain, and then we are also going to do a cross tab. So yeah, cross tab computation. After that is done, we will cluster we will filter print the filter with number of people which has an age of greater than 40, and print their count. After that is done, we'll group by marital status and align them with capital gains and mean them. So this part is done. So yeah. Then we start with data pre-processing, which is a very important one. So first of all, we will select every column and assign it in a variable, and after that is done, we are going to uh, check and filter with native countries. So we can see that there is only one person from Netherlands, so we can drop this particular data point. So after that is done, we are going to remove and filter the Holland part, Netherlands one. So after that is done, we'll create a data processing pipeline. So yeah, so we'll use string indexer for this, one-hot encoding and vector assembler. So we do all this stuff, and Then after that is done, we'll create a pipeline using an inbuilt pipeline function from PySpark.ml. This is our pipeline. So after that is done, we are going to build a logistic regression model. So this part, and then we are going to split the data set between training and testing. So that is done, and then we will print the coefficient after training it, fitting the model and training the coefficient. So this is the prediction label and probability. After that is when we are going to print the model accuracy, which comes to be 82.654%, and we also do a binary classification evaluator to, yeah. So after that is done, we'll do hyperparameter tuning. So this is how we do it, and it increased our accuracy from previous 82%. This was the basic tutorial part, and after that we we use machine learning model to train on UCI dataset. So this is how I done. So first I created a function known as convert to float, and then I imported all the dataset point, test, train, by test, and by train. So and first of all inserted every data set, imported every data, sorry, and converted them to float. We did for training and testing. Then I print their length, and after that as okay, so yeah, after this was done, so since we already used logistic regression in our previous tutorial, we can't use that, so I used uh, naive Bayes. So this is how I done it. We trained the model over here, and after training I got an accuracy of 83%, and we do the same thing for testing, and in testing I got an accuracy of 85%, and after that I predicted the F1 score, which is comes to be 85%, which is pretty good. And after this is done, the last part was to import the data on Amazon S3 bucket and create an Amazon EMR and perform the same thing over there. So I created an S3 bucket and imported all the data set. So after that I created a EMR machine and started a uh, Python Jupyter notebook over there. So there are the few changes, like the first one was the file name. So since it was not in a local system and on S3 bucket, so we uh, modified that line, and this is basically the same code with a few modification. So we trained the dataset, and we got a accuracy of 89%, training accuracy. Testing accuracy was again 85%, and F1 score was 87%. So that's it from my side, and now Hadoop part will be demonstrated.